Module 3 Geometry and Measurement. Question 1. The following diagram shows a cargo ship viewed from above. The shaded region illustrates the part of the deck on which shipping containers are stored. Part A. What is the area in square meters of the shaded region? For this, we are going to separate the shaded region into two areas, Area 1 and Area 2. Area 1 equals length times width because it's a rectangle, so it's 160 times 40, that is 6,400 square meters. Area 2 is also a rectangle, and that is 25 times 12, which is 300 square meters. So the shaded region equals Area 1 plus Area 2, which is 6,400 plus 300, that is 6,700 square meters. Each shipping container is in the shape of a rectangular prism. Each shipping container has a height of 2.6 meters, a width of 2.4 meters, and a length of 6 meters, as shown in the diagram below. Part B. What is the volume in cubic meters of one shipping container? The volume of a rectangular prism is length times width times height, that is 6 times 2.4 times 2.6, that is 37.44 cubic meters. Part C. What is the total surface area in square meters of the outside of one shipping container? A rectangular prism has three sets of equal sides: the front and the back, the top and the bottom, and the left and the right sides. Therefore, the total surface area of a shipping container is equal to 2 times 6 times 2.4 plus 2 times 2.4 times 2.6 plus 2 times 6 times 2.6, and that is 72.48 square meters. Part D. One shipping container is used to carry barrels. Each barrel is in the shape of a cylinder. Each barrel is 1.25 meters high and has a diameter of 0.73 meters, as shown in the diagram below. Each barrel must remain upright in the shipping container. What is the maximum number of barrels that can fit in one shipping container? First of all, the diameter of the circle is 0.73 meters. So, to calculate the number of barrels per length of container, we divide 6 by 0.73 and we get approximately 8. We are going to do the same to calculate the number of barrels per width, but this time we divide 2.4 by 0.73, and that is approximately 3. Because the height of a barrel is 1.25, to calculate the number of barrels per height, we divide 2.6 by 1.25, and that is approximately 2. So the total number of barrels in the shipping container is 8 times 3 times 2, which is 48. Question 2. A cargo ship travels from Magadan, 60 degrees north, 151 degrees east, to Sydney, 34 degrees south, and 151 degrees east. Part A. Explain, with reference to the information provided, how we know that Sydney is closer to the equator than Magadan. Magadan is 60 degrees north of the equator, while Sydney is 34 degrees south of the equator. The equator is at 0 latitude, therefore the angle from the equator to Sydney is smaller than the angle from the equator to Magadan. Therefore, Sydney is closer to the equator than Magadan. Part B. Assume that the radius of Earth is 6,400 kilometers. Find the shortest great circle distance between Magadan and Sydney. Round your answer to the nearest kilometer. The angle between Magadan and Sydney is 60 plus 34 equals 94 degrees. Therefore, the distance we are looking for is equal to radius of Earth times pi divided by 180 times 94, which is equal to 10,500 kilometers. Part C. The cargo ship left Sydney 34 degrees south, 151 degrees east at 6 a.m. on 1st of June and arrived in Perth 32 degrees south, 116 degrees east at 10 a.m. on 11th of June. There is a 2-hour time difference between Sydney and Perth at that time of year. How many hours did it take the cargo ship to travel from Sydney to Perth? Sydney is further east from the first meridian than Perth. Therefore, 6 a.m. in Sydney is 4 a.m. in Perth. From 4 a.m. on 1st of June to 4 a.m. on 11th of June, there are 10 days. 10 times 24 equals 240 hours. Since the cargo ship arrived at 10 a.m., then the total travel time is 240 plus 6, which is 246 hours. Question 3. The following diagram shows a crane that is used to transfer shipping containers between the port and the cargo ship. The length of the boom, BC, is 25 meters. The length of the hoist, AB, is 15 meters. Part AI. Write a calculation to show that the distance AC is 20 meters. Using Pythagoras' theorem in the right-angle triangle ABC, we have AC squared equals BC squared minus AB squared. Therefore, AC equals square root of 25 squared minus 15 squared, that is, square root of 400 equals 20 meters. Part 2I. Find the angle ACB. Round your answer to the nearest degree. In the right-angle triangle ABC, we can use either sine or cosine or tangent because we know the three sides. We are going to use sine for this question. So sine of angle ACB equals AB over BC, which is 15 divided by 25. Angle ACB equals sine to minus 1 of 15 over 25 to the nearest degree equals 37 degrees. Part B. The diagram below shows a cargo ship next to a port. The base of the crane is shown at point Q. The base of the crane Q is 20 meters from a shipping container at point R. The shipping container will be moved to point P 38 meters from Q. The crane rotates 120 degrees as it moves the shipping container anti-clockwise from R to P. What is the distance RP in meters? Round your answer to the nearest meter. Using the cosine rule, RP equals square root of 38 squared plus 20 squared minus 2 times 38 times 20 cos 120 degrees equals 51 meters. Part C. A shipping container is a rectangular prism. 4 chains connect the shipping container to a hoist at point M, as shown in the diagram below. The shipping container has a height of 2.6 meters, a width of 2.4 meters, and a length of 6 meters. Each chain on the hoist is 4.4 meters in length. What is the vertical distance in meters between point M and the top of the shipping container? Round your answer to the nearest meter. We are going to construct the right-angle triangle MON because we need to calculate OM. However, we do not know the distance NT. For this, we are going to construct the right-angle triangle SNT. Using Pythagoras' theorem in the right-angle triangle NST, NT equals square root of 6 squared plus 2.4 squared, which is 6.46 meters. We need the side length NO in triangle MON. So NO equals 6.46 divided by 2 equals 3.23 meters. We are going to use Pythagoras' theorem again, but this time in the right angle triangle NOM. So MO equals square root of 4.4 squared minus 3.23 squared equals 2.99 meters. Correct to the nearest meter equals 3 meters.